Hey, hi everyone. Good morning, good evening. My name is Kumar Bollineni. I'm having 12 years of experience in SAP ERP solutions. In this conference, we will discuss how generative AI is revolutionizing business intelligence in cloud ERP ecosystems. In this presentation, we will mainly focus on how generative artificial intelligence can revolutionize predictive analytics capabilities within ERP cloud systems. We will examine how advanced machine learning models, particularly generative adversarial networks, integrate with existing ERP infrastructures to transform forecasting accuracy across multiple business functions. And through the technical foundations and implementation strategies and cross industry case studies, we will demonstrate the tangible business value while addressing critical challenges in data quality, system architecture, and model maintenance. You will gain a strategic roadmap for leveraging generative AI to achieve competitive advantage through enhanced operational efficiency and data driven decision making. So, as an example, like Siemens uses generative AI in its team center ERP system to simulate supply chain disruptions and generative optimal recovery plans, improving resilience. So the next one, what we are looking at is evolution and market trends. So we are differentiating the market trends by three different ones. So unprecedented growth. So the global AI in ERP market is expecting rapid expansion with projections indicating a compound annual growth rate of 29.7% through the 2030. So the Microsoft Dynamics 365, as an example, 365 Dynamics 365 AI integrates with ERP system, contributing a projected by 30% CAGR by 2030. So widespread adoption. The second market trend is widespread adoption. Approximately 65% of large enterprises now incorporate some form of AI capability within their ERP ecosystems, a significant increase from previous implementation rates. As an example, Walmart uses AI in its ERP for inventory management and reducing the stockouts by 30%. And the next one, what we are looking at is industry leaders. So the accelerated adoption is particularly evident in manufacturing, retail, and healthcare sectors, where complex operational requirements create compelling use cases for predictive capabilities. So, as an example, like Johnson employs AI in SAP ERP to optimize pharmaceutical production schedules. So, the next one, what we are looking at is the next one we discuss about. The next section, what we will discuss about is technical capabilities and business value. So here we have three different capabilities here. The first one is enhanced decision making. Organization implementing AI enhanced ERP systems reports substantial improvements in decision making process with 78% of early adopters documenting enhanced operational outcomes through more accurate forecasting and predictive maintenance. As an example, Coca-Cola uses AI in SAP ERP to forecast regional demand and reduced waste by 20%. The next one is efficiency improvements. Companies reports an average reduction of 35% in manual data processing requirements following successful deployment, creating compelling financial justification for implementation. As an example, Unilever automated processing in its ERP, cutting manual work by 40%. And so the next one is deployment models. Cloud-based implementation has become a dominant paradigm, offering scalability and computational resources necessary for advanced modeling, training, and interference. So Netflix leverages SAP ERP Cloud with AI for real-time content licensing cost analysis. Through that, they are reducing a lot of cost, which is getting implemented as part of the cost analysis. Okay, the next one, what we are looking at is architectural framework for AI and ERP integration. So here we have a different layers approach, a five-layer approach where we can integrate AI and ERP together. So the first one is a security layer where we will ensure data protection and compliance when we are integrating with AI to ERP. And the next one is a technology layer where we provide the computing infrastructure which enables the integration of AI and ERP. And the next one where we manages the information flow and the storage of data using data layer. And the next one, how we handles the business logic and processing using the application layer. And the last one is a presentation layer where the user interface and experience is delivered. So through this five-layer approach, successful implementation follow this structured approach, incorporating five key architecture layers. So this framework enables organizations to maintain clarity regarding system boundaries, integration points, and information flows while implementing advanced AI capabilities. As part of this security layer, as an example, Pfizer's ERP uses a blockchain for HIPAA-compliant data encryption in clinical trials. That is one of the biggest layer where everyone needs to ensure everything is secure. The data compliance, data protection is one of the major data driven point when we are integrating with AI with ERP systems. Next one, what we are looking at is cloud infrastructure and data management. How the infrastructure. So the next one, what we are looking at is a cloud infrastructure and data management. So in this section, we will discuss how the infrastructure and data management can be handled. What are the benefits of cloud? And also how the integration works between the data and data governance. So the first one, what we are looking at is cloud benefits. Some organizations implementing AI solutions experience substantial benefits from cloud deployment models, with infrastructure scalability representing a primary advantage. Modern implementations leveraging the infrastructure as a code approaches to ensure consistency and repeatability. As an example, Airbnb uses global clouds AI tools to scale ERP resources during the peak booking seasons. So the next one, what we're looking at is data governance. Successful implementations employ canonical data models that normalize terminology and formats across organizational boundaries. Organizations must establish clear policies regarding data ownership, quality standards, and usage permissions. Procter and Gamble employs a canonical data model in its ERP to standardize global supply chain terminology. So, as an integration approach, data pipeline automation maintains data freshness with real-time and near real-time data integration, enabling more responsive predictive models. Hybrid approaches optimize both data governance and analytical performance. Next one, what we are looking at is supply chain optimization through AI. So, because of this optimization through AI, 23% average improvement compared to traditional time series approaches, and also 3 plus successful implementation combining ERP data with external factors. So, which results substantial reductions while maintaining service levels. Organizations implementing AI driven forecasting models experience significant improvements in supply chain operations, particularly when addressing demand volatility from market disruptions. The technical implementation typically follows a phased approach, beginning with data integration, followed by model deployment, and culminating in interactive dashboards for scenario evaluation. So, as in supply chain example, Tesla combines ERP data with weather APIs to optimize battery supply chains, reducing delays by 25%. That is a huge reduction in delays for the Tesla. So the next one, what we are looking at is financial planning and production optimization. So when we are implementing machine learning into ERP, so we are looking at two different techniques here. That is, one is financial forecasting. Organization enhance financial forecasting accuracy by implementing machine learning algorithms that identify complex relations between organizational metrics and financial outcomes. So JP Morgan uses machine learning in Oracle ERP to predict cash flow trends with a 90% of accuracy. The next one is production scheduling. Companies implementing machine learning algorithms for production scheduling experiences average reductions of 18% in production lead times compared to traditional approaches. So Toyota reinforcement learning system in SAP ERP cut the production lead times by 18%. So the reinforcement learning, advanced implementations employ reinforcement learning techniques that continuously improve the scheduling policies based on observed outcomes, gradually adapting to changing production constraints. The next one, what we are going to discuss about is how the manufacturing sector's implementation will impact the usage of machine learning in the ERP sector. So here we defined into four different sections. The first one is requirement gathering, where where we will define business objects and the technical requirements for the sector. And also the next one is data preparation, where we will validate data quality and integration, diverse sources. As part of the development, we will create and train predictive algorithms so that those algorithms will be deployed at the time of usage. And the fourth one is integration testing. Verify the system's compatibility and the performance as part of your integration testing. So, an automotive parts manufacturer is implementing an AI-enhanced forecasting system that delivered remarkable operational improvements. This solution incorporated both supervised and unsupervised learning techniques to identify complex patterns in production variability that traditional statistical methods had to fail to detect. So overall, when we are implementing in the manufacturing sector, when we implement both ERP and machine learning, we will see lot of implementation cases. So as an example, BMW AI enhanced ERP reduction, reduced production variability by 30% using GA GANs. The next one, what we are discussing about is how the retail and healthcare works when we implement AI in the into ERP systems in AI. So why we are using, for example, the retail demand sensing. In retail demand sensing, multi-channel forecasting with external variables. Jara's Oracle ERP integrates social media sentiment analysis to adjust the inventory weekly. Based on the social media, they performed more sales based on the sentiment, how the social media works. And the next one, what we are looking at is compliance integration, whereas HIPAA complement data handled protocols. In the healthcare system, Mayo Clinic uses Epic ERP with AI to predict the patient admissions, reducing wait times by 15%. And also the next one is markdown reduction, improved allocation and timely replenishment. When we use the AI, that's what it happens. It will improve the allocation and timely replacement. The next one is healthcare resource planning, optimized staffing and capacity utilization. So when we integrate with a multi-channel retailer deployed a comprehensive predictive analytics solution that incorporates social media sentiment analysis and competitor pricing data and regional economic indicators to generate more accurate sales forecast. Similarly, a regional healthcare provider implemented predictive analytics to optimize the staffing levels and resource utilization while maintaining the strict compliance requirement. So in the retail and healthcare sector, we will get more benefits when we integrate ERP. The next one, what we are looking at is implementation results across industries. Here we will look at multiple examples how the ERP plus AI produced results in a way it enhances the overall industry. For example, automotive manufacturing, where they implemented SAP S4HANA as an ERP system using GAN based forecasting, where it results where it resulted 37.88% of forecast accuracy improvement and 4.7 million annual inventory sales. This was what happened with the Ford SAP ERP solution. And the next one, what we are looking at is multi-channel retail. For example, let's take Amazon as example here. So they used Oracle Retail as an ERP solution and used the time series with external variables. So which resulted in substantial markdown reduction and improved the allocation percentages for Amazon. The next one, what we are looking at is in healthcare, where they used the Epic Systems as an ERP solution, where used resource optimization models as an AI technology. So as in results, it optimized the staffing and improved the capacity utilization. What we are looking at is data quality and preparation challenges. Here we differentiated into four different approaches. The first one is initial validation, where we verify the data against predefined quality thresholds. And the next one is standardization, transform to consistent format across sources. As an example, Nestle ERP cleanses supplier data using AI and improved PO accuracy by 35% as part of the standardization. So the next one is enrichment. So here we have to add derived features and contextual information, which results in the final verification, confirms the readiness of model ingestion. So organization implementing AI-enhanced ERP systems must address several critical data challenges, including inconsistency across sources, incompleteness of historical records, and semantic ambiguity. These adopting semantic data preparation methodologies experience significantly higher implementation success rates compared to those making ad hoc approaches. Okay. In the next section, what we are looking at is integration architecture considerations. Here, we look at successful integration requires developing locally coupled frameworks that isolate AI components from underlying ERP systems, enabling independent evolution while maintaining functional integrity. The technological architecture generally incorporates specialized middleware components that abstract the complexity of underlying ERP systems, providing standardized interfaces for AI services. So here, when we compare between different layers like the middleware layer, event-driven architecture, API component, integration patterns, error handling. So when we are comparing between implementation complexity and the business impact is more. The implementation complexity is there, but still the business impact because of the implementation is huge. That's where we need to consider implementing AI plus ERP. The next one, what we are talking about is model management and governance. So as part of this, we need to look for 5 different sections. So the first one, what we do is create and train models with appropriate validation as part of the development. Once the development is completed, verify the performance against business requirements. This is as part of the validation. Once the business requirements were verified, then we will implement the same in production with monitoring capabilities. And then we will monitor to track the performance and trigger alerts whenever they require. And then finally we replace outdated models with improved versions that will give the more higher results. So organizations implementing robust model governance processes experience substantially lower operational incidents while maintaining higher prediction accuracy over extended periods. The technical implementation typically incorporates automated monitoring capabilities that track model performance against established metrics, triggering alerts when predetermined thresholds. And what we are looking at is future direction. So here in this section, we will discuss how multimodal AI and edge computing will result in different sectors. So multimodal AI integration, advanced systems that process diverse data types simultaneously, including structured ERP data with unstructured content like texts, images, audio, and video to create more comprehensive predictive models with enhanced accuracy and expandability. As an example, GI Healthcare combines MRI images with ERP data to predict equipment maintenance. The next one is edge computing architecture, the distributed intelligence that processes data locally at operational endpoints, including manufacturing facilities, retail locations, and logistics centers, reducing the latency while enhancing the resilience and data for geographically dispersed operations. This one used by Shell. Shell deploys edge AI in oil rigs to process sensor data locally, reducing the latency by 60%. The next one, what we are looking at is model optimization. Is advanced techniques including quantization, pruning, and knowledge distillation that reduce computational requirements while preserving critical predictive capabilities for deployment across diverse computing environments. So this is the future how it is going to be look like. So the next one what we are looking at is the roadmap. So roadmap and conclusion. So as part of this we will look at the phased implementation, strategic assessment, and organizational alignment. So as part of the strategic assessment, evaluate organizational readiness and identify high value use cases that align with business objectives. Establish clear success metrics and governance frameworks for implementation journey. And the next one, what we use is we need to follow the phased approach. Follow a structured approach with proof of concept validation, scale development, and continuous improvement. This enables progressive capability building while demonstrating value incrementally. So the next one is organizational alignments. Establish a dedicated centers of excellence, combining technical specialists, business domain experts, and change management professionals to ensure successful adoption and ongoing optimization. The integration of generative AI with ERP cloud system represents a significant advancement in enterprise technology capabilities. Organizations that effectively harness these capabilities gain substantial advantages through improved forecasting, accuracy, and enhanced resource allocation, and more agile responses to market fluctuations. Hey, thank you everyone for attending this conference. Please reach out to me on if you have any questions regarding implementing ERP and AI, artificial intelligence in ERP systems, that will give huge benefits to all the industry sectors. Thank you.